In this recording, we're going to continue studying simple linear regression, specifically creating regression output, finding the equation of the line in that output, and most importantly, interpreting the equation that comes when we create that output. If you recall, we were looking at a data set that did not have great correlation, where we were looking at advertising dollars in hundreds and sales of a product in thousands. We created the scatter plot, which gave us a visual that looked like this, and in a cheat method that I am completely acceptable of, we picked a point on here, we right-clicked, and we said insert or add trend line. And since it's linear, we chose linear, and we generally displayed the equation in the R-squared directly on here. However, now we're going to actually create the regression output that would go with a data set that had one variable that we were considering to be the independent variable, advertising, and one variable that we'd be considering to be the dependent variable, sales. In order to create regression output, we would go to the data function on Excel. Now, if your data function does not have analysis toolpack yet, which is missing from this, we need to add it in order to do the simple linear regression. If you're using a Mac that is not on the window-based side, you will need to look up these instructions because they will not be exactly the same. If you're using a window-based Excel product, you would go to File, you would come down to Options. Under Options, you would choose Add-ins. Within Add-ins, you would come down to Analysis Toolpack. With the Analysis Toolpack, you do not want to click OK. You want to click Go, and then see that it is clicked, the Analysis Toolpack, and click OK. So now, when I want to create my regression output, what I am going to do is I'm going to come to Data, and you'll see that now I have data analysis as a possible tool. Sometimes you have to unclick it and click it again because mine wasn't showing up, but now that we have it, we want to go to Data, Data Analysis. So the data is the top tab up here. We click on Data Analysis, and we're currently working on regression. So we're going to come down alphabetically to the word regression. We click OK. It'll first ask what your Y value is. We believe that our dependent variable is your sales. Notice I highlighted from B1 down to B21, including the title. And I think the X variable, seems that I've switched sheets here. My X variable, on the other hand, would be the advertising. So I start at A1 and go to A21. Now because I kept the headers in the top, I would click Labels. I don't know what it's doing. And when I look at this, I'm going to have my Y variable as sales from B1 to B21. My X variables is advertising. I've clicked Labels, and I'm going to click OK. When I do this, it'll take me to a new sheet. On the new sheet, it will give me what is the regression output because I didn't tell it specifically where I wanted it. In the regression output, you can find your R-squared value. You can also find a somewhat good estimate of the correlation coefficient. But most importantly, we're looking for the equation of the line, which can be found underneath of the word coefficients. And so when you're looking at the output, if you look underneath of the word coefficients, the first point that it gives you is the intercept, and the second point that it gives you is the slope. And so if we were going to write this underneath of coefficients, we would get y hat is equal to 105.189 plus 1.2447 times x. Now, each of these points is important. When we find these, it should match directly with what we had found on the picture. When we looked on the picture, we got the equation 1.244x plus 105.19. That is the same answer that we just got when we looked at our output, 1.244x plus 105. So the equation won't change, but when we get to multiple regression, we won't be able to get it from the scatter plot, and therefore we'll need to make and interpret the output. So looking at our regression output, underneath of the word coefficients, we get our equation. And the most important piece of information, while the equation is great, and it's usually a very useful piece of information in that it will help you make predictions, It makes no sense to anybody who's not directly and very closely involved with the data, and sometimes not even to them. And that is because it needs to be interpreted. If you don't interpret an equation, you lose the ability to share the data that you found with someone. And so while giving me an answer like this, 105 plus 1.244x shows me that you can run an Excel file, it does not help you to share information with me that shows you know what you just did. So it's important that we think of it as y equals mx plus b. When we talk about y equals mx plus b, it's called the slope-intercept form, and you've been dealing with it probably since about 7th grade. And it's vital that you consider what those pieces of that equation are. One piece is called m, which is known as the slope. Now the slope, sometimes known as rise over run, the better definition, the one that's more accurate and shares information that people could use, is that the slope is the change in y for every one change in x. Change in y for every one change in x. This sentence, until you get really comfortable doing analysis and interpreting your output, is vital. You need this sentence, because if you can use this sentence, it'll start to make sense to you what is happening with the data. So in this case, our slope is our change in y for every one change in x. It's always going to be the same. For the model we just got, we have 1.2447x is, well, 2 is our slope. And since we know what our x and y is, we could say 1.2447 is the change in our y variable with sales for every one change in our x variable was advertising. Now remember, these are dollars, and the sales was in thousands. So if you think of it in terms of the problem, we can say $1,244.70, because it's in thousands, is the change in sales for every $100 change in advertising. Kind of like a return on investment. It helps you to really explain to your boss that if he's willing to give you another $100 in advertising, you can increase his sales by about $1,200. So being able to interpret that makes a lot more sense. The second piece of the equation, when we look at y equals mx plus b, is the b piece. The b is called the y-intercept. I know you've used the term a lot in your life, but I don't know if we've ever really thought about what the y-intercept means. We define it, but now that we're actually working with problems that we have to interpret for someone else, it's really important to think about, when you have your x and y axis, where is the y-intercept? It is the value that y takes on when x is 0. Think of that in terms of this problem. We have 105.189. That is, the y-intercept is the value of sales when advertising is 0. In terms of this problem, because it's in thousands, we could say $105,189 is the sales when advertising is 0. Okay, so what we were looking at here is we were looking at, after we've created the scatter plot, how do we make a regression output, and most importantly, how do we interpret the line that is created for the data? And so we used the data analysis ribbon. We created an output. Underneath of coefficient, we get the y-intercept and the slope, the first piece being the intercept, the second piece being the slope. But most importantly, then we have to define them to make sure we can explain to someone else exactly what the slope and the y-intercept mean.